Good evening, everyone. Guys, am I audible? Yeah, thank you. Let us start with our session for today. So, in the last session, we were discussing primarily the difference between encryption and hash. So, we were discussing more about the cryptography functions. So, before we continue, let me just revise that the main difference between this encryption and the hash, and then we'll continue with our other topic. So when you speak about protecting your data, right, there are two methods that are generally used. One method is performing data encryption. So one method is performing data encryption. Now in encryption, what happens? Whatever data you have, the clear text data, that will be converted into an unknown format, right? So whatever the clear text data you are having, that will be converted into an unknown format. So you can take a example something like this. Now let's say I have a data something like ABC123. By using a encryption algorithm, now let's say I can take something as DES or AES, some encryption algorithm. This is going to convert our clear text data into an unknown format. Now here when you speak about unknown format, you call this as ciphertext. So clear text is the data what you take or what you type, right? After encryption, you call it as ciphertext. Ciphertext contains your original data, but it is in an unreadable format. Ciphertext contains your original data, but it will be in a unreadable format. You will not be able to directly see and understand what exactly it is, but data is still present. Now this particular ciphertext, by applying the same encryption algorithm and executing it in reverse, you will get back clear text data. So on the ciphertext, if you execute the same encryption algorithm, right, you will get back the clear text data, right? So this particular part, converting clear text to ciphertext, you call it as encryption. Converting clear ciphertext back to clear text, you call this as decryption. So are you guys clear the main difference between encryption and decryption? Okay, so the other concept that we were discussing is hash. Now hash algorithm works in a completely different way compared to the encryption or the decryption part. Now for the same data, let's say for same ABC123, if I apply a hash algorithm, let's say I take up MD5, what this hash algorithm, the MD5 algorithm does, it would consider your entire data. So that data can be your password, data can be your software, data can be your source code, whatever it is. It considers the entire data as one single unit. It would consider the entire data as one single unit and calculate a value for this. And the calculated value is what we call as a hash. So this calculated value is called as hash. And the hash value will be of fixed length, right? So if I take up MD5 as an example, the hash value, whatever you are going to get, will be 128 bit, irrespective of your input. Input can be one character, or it can be 1000 characters, or it can be as a large software as big as 100 gigabytes or 1 terabyte, whatever it is, right? Irrespective of the input size, the hash value that you calculate will always be of the same length. So can we expect the hash value to contain the original data? So guys, what do you say? Can we expect the hash value to contain the original data that you have taken as the input? Guys, what happened? No response. Guys, what I'm asking is, if we look at a hash value, right, can we get back the original data? Okay, so some of you are saying, yes, we can get back the original data, and some of you have said, no, it is not possible, right? So let me clear the things. As I said, irrespective of your input, right? Irrespective of what is your input data size, the output hash value is always 128 bit in this case. If I consider MD5 hash algorithm, does it contain the original data? Now let's say I'm taking input as a 10 GB file, and the output what I got is a 128 bit hash value. Can I say that this 128 bit hash value has 10 GB data in it? No, right? We cannot say that the 128 bit hash value, whatever we have, contains the 10 GB original data. Right? So your hash value does not contain the original data. Hash value is just a calculated value for all the data. So whatever the data you have taken as input, irrespective of its size, the hash value will always be of a fixed output, right? Or a fixed output length. Okay. So encryption, you will be able to reverse it. You can decrypt and get back the data. But when it comes to hash, there is no way of reversal. Hash is a one-way process. Encryption, you can reverse it, you'll get back the original data. Okay, is that clear, everyone? Right? Yeah. So when you speak about the cryptography part, to protect your data, you will either use the encryption methods or the hash methods. Right. So now you guys are clear with the concept. Now, where do we use encryption and where do we use hash? So in what condition should we use encryption and in what condition we use hash? So here, there's a very clear difference here. You use encryption when you have to transfer data from one system to the other system. Right, from one system to other system, if you have to transfer data, you're going to use the encryption methods. You encrypt all the data on the source, let the destination system decrypt it. Right. You use hash value to make sure that whatever data you are exchanging, whatever data you are transmitting, right, has not been manipulated. To verify if the data, whatever you have sent, right, is intact or not, to verify the data integrity, you are going to use the hash. So to transfer data from one location to the other location, one computer to the other computer, right? Maybe they are both part of the same network, same organization, or maybe they're on in two different locations on internet. In both cases, for data protection, you use encryption. For data integrity checks, you are going to use the hash values, right? So here I have a simple website which we can use for uh, creating a hash value and to create uh, encryption and all. So let me share my screen so we will also be able to check that. I'll show you with the website so you'll also be able to understand how exactly it is. Okay, so I hope you're all able to view my VM. Yeah, okay, thank you. Okay, so I'll use a web page, right, using which I can perform encryption. Okay, so this is a website. Now here I can type some text. Now let's say uh, I'll type something as hello, welcome to cybersecurity professional. So I'm just typing some normal text. So this is the clear text data. And now when I click on encrypt, this particular data, whatever I have typed here, right, whatever was there in the clear text, this will be encrypted. Now you see, this has been encrypted and this is the encrypted message. Okay, so this is the encrypted message what we have from the web page. Right. Next, we will also see how do we reverse it. That's what we call as decryption. So for reversing this, right, I'll just give the encrypted text here, right, and say decrypt it. Now when I say decrypt it, it's going to decrypt. It is going to reverse that encryption and show us the clear text data. So is everyone clear? How you can use this web page. So this is as an example for you to get an understanding what is the encryption and decryption part, right? So you can encrypt the data and you can also reverse it. Now, if you see, when I'm doing the encryption, I've typed something which is clear text. So just by looking at it, we will all be able to read and understand what it is. But once I click on encrypt, it has given me some data, right? So it has done the encryption. Now here, if you see, it has all the English characters and symbols and all what we can recognize. But can we read and really understand what is this data? We will not be able to read and understand what it is. But then on the same web page, we also have the decryption tool. So when I give this encrypted text here and say decrypt, it has reversed the ciphertext. So it has done the reversal. Ciphertext has been converted back to clear text. Right. So is everyone clear what happens in case of encryption and decryption? Okay. So now let us see how we can go with the hash. So to calculate hash value and to verify, I'll go with a different web page. So let us access this website. This will help us to create a hash value. So let us see that. Okay, so let me type the same text, hello, right? Yeah, you're all able to see this, right? So this is what I have typed, hello, and I say generate. Okay, yeah. So now you see it is showing us the data, what was the text that we have typed, and what is the calculated hash value. So I'll keep it here. Okay, so this is the string what I have typed, and as you can see, it is showing us both MD5 as well as SHA-1 hash algorithms, right? So what is output by running two different algorithms, right? So MD5 is a hash algorithm in the same fashion. SHA-1 or secure hashing algorithm, this is a different hash algorithm. So it has executed both and it is giving us the result of that particular hash. Now, let me make a small change in the input text. Now, as you all see, I've given the string as hello, uppercase H, right? Let me change this to lowercase h and try to generate hash values. Then we will compare if the hash values are same or did they change. Okay, so now we have the hash values. Copy. So guys, is the hash value same or did it change? So the hash value has changed, right? So as a user, right, as a human, when you see both are same, hello is the same word, but there's a very small change, one character, right? In the first string, the first character what I have used was in uppercase, and then it is a lowercase character. So there's only a small change, only one character has changed. But see the hash value, the entire hash value has changed. So that's what I was explaining. When you speak about hash, it would consider your entire input as one single unit and calculate a value. The hash algorithm is going to consider your entire input as one single unit and it is going to calculate a hash value, right? So even for a small change, just like uppercase and a lowercase, right? You see, the hash values are completely different. Now let's say I'll just try to add a dot and then try to recalculate the hash values. We'll see if the hash values will be the same or will it change. So what is your guess? Will it be the same or will it change? It will change. So now let us verify this again. So see, again the hash values have changed. Right. So here when you speak about a hash, it's going to consider your entire input as one single unit and calculate a value for it. Right. And here instead of just one simple word hello, right, I can put up anything. So I can just copy this entire paragraph and then try to create a hash value, right? So as I said, irrespective of your input, right, the length of your calculated hash value is always going to be the same. So let it give us a hash value. We'll copy the hash value and we'll see if the length is same or has it changed. So I'm not copying the entire input string. We just wanted to see the hash value length. So only copying the hash value length is okay. Now we see the MD5 hash value, whatever was calculated, right? For a simple string hello and for an entire paragraph, is the length same? MD5 hash value length, is it same? Hash value output length is same. Same way, SHA-1 hash value output length is also same, right? So irrespective of your input might be 1 character or 1000 characters, right? Your calculated hash value is always going to be of the same length. So by looking at this hash values, can we confidently say that the hash value does not contain your original data? Yes. Hash value does not contain your original data, right? Can we reverse the hash? So obviously when hash does not contain the original data, there is no question of reversal, right? So is everyone clear? The difference between encryption and hash? Yeah. So then coming back to our discussion about the encryptions and the hashes and all. As I said, when you speak about data, when you have to send data from one system to other system, you are going to use encryptions. And for data integrity check, you are going to use hash. So not only for data integrity check, hash values are also used in other locations, especially when you speak about your passwords. Now, are we using passwords everywhere? On our computer, online accounts, our mobile devices, and all these things? So we are using passwords everywhere, right? So now coming back to your system, right? Your computer or maybe your online website or wherever you are trying to type a user ID and password. Wherever you have this password, obviously you also have a username or a user ID associated. And along with the username or user ID, you are also giving the password. Now these systems, maybe the websites or operating systems, Do they protect both usernames and passwords, or do they only protect the username, or do they only protect the password? So what is your guess? Does your operating system or the website, whatever the authentication system that you have, does it protect both the username and the password also, or does it only protect the username or only the password? Okay, so here when we speak about the authentication systems, they do not protect your username or your user ID. So this is always going to be in clear text. What is being protected is your password. Your password is the one which is protected, right? And generally, uh, when you speak about the password, this will be saved as a hash value. So it's not going to be encrypted. It is going to be saved as a hash value. So when you are creating a user account, maybe say you have given some username as say, uh, let's say you have given some username Zoom and you have given some password as Zoom at the rate 123. So this is the user ID and password what you have used when you are creating the account. So this password Zoom at the rate 123 what you gave will not be saved as Zoom at the rate 123. It will be converted into a hash value, and that hash value will be saved on the system. So it can be on your personal computer, or it can be on a server somewhere on internet, right? So this hash value will be saved as a password hash value, right? So it's not the clear text password, but it is the hash value that is being saved. Okay. So is that clear, everyone? Where we are using this hashes. Okay. So now coming back to our discussion, earlier I said the first technique that hackers are trying to use is try to identify a vulnerability, and based on the vulnerability try to launch an attack and compromise the system. That's one method. The second method, hacker tries to crack our password, and once a hacker is successful in cracking our password, then hacker tries to access our resource. It can be a server, it can be a system, it can be a router, whatever it is. It can be a user account. Hacker tries to access this resource after cracking the password. So now let me take up a scenario where I assume hacker is in my network. So earlier when we are speaking about the vulnerabilities, we were assuming that hacker is somewhere on internet. But now let us assume that hacker is in our network or our office or our location, right? So if hacker is in our network, hacker is in our office, does a hacker really need to go through footprinting, identifying vulnerabilities and all that stuff? So should the hacker really take this route, identifying the vulnerabilities? If hacker is somewhere on internet, because hacker doesn't know anything about our network, hacker doesn't have any information about our networks and all, hacker is going with the footprinting, identifying the running systems, identifying open ports and all that stuff. But if hacker is within the network, not really necessary, right? Hacker can simply go with the password cracking method, which is easy. And not only easy, practically speaking, for a hacker who is already in your network, footprinting is not required because hacker already knows what operating systems and applications are being used in the organization, what range of IP addresses are used, what kind of applications are being used, right? And then speaking about scanning, assume you are a hacker, right? And you are in the same network, you are connected to the same network. Can you perform scanning without being identified by the administrator? Because in scanning, what happens? You'll have a direct connection from your computer to the target, right? And assume this is all happening within the same network, within the same LAN. Is there a chance administrator can identify what's happening in the network? Yes, and you don't want to be caught, right? So you'll not be able to go with the scanning part, whether it is IP scanning or vulnerability scanning, whatever it is, you will not be able to do that. So the other alternate option, crack the passwords, right? So now, as I've already said, I'm assuming a scenario where hacker is in our network, right? Hacker is one among us, right? Now this guy, hacker, let us say, has physical access to my computer or physical access to admin computer. So hacker is in our office and hacker also has physical access to the administrator's computer. So if hacker has physical access to the admin computer, can a hacker try to see what data is present on admin's machine and maybe try to initiate some request from admin's computer itself, trying to access other resources and all? There is a possibility. And the only thing that is stopping the hacker from accessing all the data on admin's computer is the password of that computer. Is that correct? So whatever the password that administrator has set for their user account, right? That password is the only thing which is stopping the hacker from accessing all the data on the admin's computer. Do you agree? So now let us see if a hacker will be able to bypass the password or not. But before we discuss that, I want, what is your opinion? Will a hacker be able to bypass the user account's password of the admin computer and log into that system? So yes, a hacker will be able to bypass the authentication of admin's computer, right? Hacker can bypass it, right? So there are different methods, right? Now let's say uh, I'll try to show you with two different methods, right? If the admin computer is something like, say, a Windows 7 system, right? Or a Windows 8 system, there is an application called Conboot, right? If it is Windows 7 or Windows 8, there's a tool called Conboot using which a hacker can try to bypass the authentication. If it is Windows 10 or Windows 11, right, then hacker has to use something like uh, Hiren's boot CD. Right? So to bypass the administrator account's password, based on what operating system is used on the admin's computer, there are different ways. Either use the Conboot or use Hiren's boot CD. Now, when you speak about these two tools, both are available as bootable ISO images, right? So you can either burn them onto a CD or a DVD, right? Or you can create a flash drive. A USB flash drive can be created, right, for this Hiren's or the Conboot. Mr. Bright, cross-site scripting will not be helpful here because on your computer, the authentication systems are not based on web logins. So cross-site scripting will not work here. So I'll show you both the techniques, the Conboot application as well as the Hiren's boot CD, the application. Right? So let me start up my VM. Let's say I'll try to start this Windows 7 VM, right? And then we'll go back to the Windows 11. So as you see, my Windows system is booting up. Okay, so once the operating system is up, as you see here, it is asking you to type a password. So without typing a password, you will not be able to log in. So it gives you an error, right? So now what I do is I'll just shut down this machine and then I'll try to boot it using conboot. So as I said, you have an option to either go with the ISO image and then burn it onto a CD or a DVD, or you can create a live bootable USB. So I'll try to use conboot ISO image. So on the virtual CD-ROM of this VM, I'll insert the conboot ISO and say start up the computer. So now see, when I insert the conboot ISO image, instead of directly booting up my Windows operating system, it would first try to boot the conboot application and then it will go to the Windows operating system. So let it start, we'll see. It's taking so long. Okay, my VMware workstation for some reason it's not responding. It is busy, so let us wait. Yeah, so it started responding. Give me a minute. Let me check why it's unable to boot from the ISO. Not even responding. Workstation. Yes, image. Okay. Mm, so this seems to be the issue. Okay. Let me just once do it on Windows 11 machine. Looks like my VMware, it's having some difficulty booting it with the ISO. We'll see. Guys, if any one of you have updated to VMware Workstation 17, don't do it. So my mission, I think it got updated to VMware Workstation 17, and I see there is some issue for booting up from ISO. So let me just check it with the other VM. Seems to be stuck in the BIOS setting for that Windows 7 machine. So we'll see what's in this. Okay. Yeah. So I'm trying to boot up from the CD-ROM. So that's where I have given the Hirens boot CD ISO image, right? So I'm trying to boot it from it. So let it boot. Uh, I'll show you how you will be able to bypass the password. So as you see, this is how the Hirens boot CD would start up. Right? Give me a second to change the keyboard layout. So on the Hirens boot CD, you go to the start menu, right? Just looks like your Windows 10 start menu user interface, right? So here, go into the security tab. So within security tab, you find a folder called passwords. So within the passwords, right, you'll see different applications are available for you to bypass the password and all, right? So you can try with all these password bypassing applications, right? Because it varies based on the version of Windows 10 or Windows 11, because Microsoft regularly keeps making changes so that they can prevent this kind of bypass method. So you try with all the three options that are available here. So let me first start with the Windows password recovery application. So the option I am choosing here is to reset the Windows password. Say next. Okay, so it gives you a warning that this software should not be used for commercial purpose and all, right? So anyway, say okay and then continue. Now it is identifying your Windows installation as Windows 10. So don't worry, even though Microsoft calls it as Windows 11, right? Technically, it is Windows 10 update, right? So internally, while the Windows 11 operating system was being developed, it was still being called as Windows 10 itself, right? So every software will identify your Windows 11 as Windows 10, except for when you go into the control panel and you see your system details, right? So every other third-party tool will not be able to differentiate Windows 10 with Windows 11 because Windows 11 is basically Windows 10 itself. So here, once you say next, it shows you all the available user IDs, right? So select the user account whose password has to be reset. You can say next, right? And then click on this blue button which says reset or unlock. So the password has been reset. You can say finish and then you can restart the system. So it said that your password has been reset. So you can just try to reboot the system. So once it restarts, it will not ask you for a password, right? Okay, so on my machine, so it shows me the user ID. Uh, it does not ask me to type any password. I'll just click on the sign in button and I'll be able to log in. Okay, so my Windows update has been pending for some time. So let me just skip that. Okay, so as you see, if a hacker is in our network and hacker has physical access to our computer, right? Hacker can try to bypass our login and directly gain access to our system. Right. So is it clear how a hacker is able to bypass? Barco, what do you mean by default Windows? What I have reset password is for the Windows operating system itself. If it is on a virtual machine, you are able to give the ISO image. If it is on a physical computer, as I said, you'll have to use a CD or a DVD, or you'll have to flash the contents of that high-res boot CD onto a pen drive and start booting it from the pen drive. Okay, is it clear? Yeah. So if a hacker has physical access to our computer, right, hacker can reset our passwords or bypass our passwords. So how can we prevent this? Is it possible? You can prevent this from happening provided your systems have physical security. Physical security in the sense, in your absence, no one should be able to access your machine, right? So if you can ensure that physical security is taken care of, then this kind of issues can be prevented, right? Mr. Bright, when you say like the external drives are prevented, right? Now there are two methods what administrators use to prevent these external drives. One method is by permanently disabling the USB from your system motherboard. So on the motherboard BIOS settings, they can directly disable the USB devices. But unfortunately, that will not be of any use today because even your input devices are all based on USB now. So they will not be able to disable the USB from the motherboard settings. The second option is once your operating system boot up, means once it is completing the booting procedure, then using group policies, administrator can disable end users from connecting the USB devices and all those, right? But in this case, when you are using Hiren's boot CD or even con boot, you are not even letting your operating system to boot up, right? So you'll be using con boot, right? That would be the first booting option. So con boot will first boot up and then your operating system will boot up. So by the time your operating system is booting up, Conboot has already loaded itself into the RAM and it is able to bypass the authentication. And same thing happens with the Hirens also, right? So even that group policy, which is preventing end user from connecting the USB devices, will not be blocking the hacker in this case. So that's the reason I'm saying to prevent these kind of things from happening, we have to implement physical security. So in the absence of the user, no other unauthorized user should be able to access that particular device. It can be a desktop, it can be a laptop, it can be your server or any other network device. Is it clear, everyone? Okay. So now, as I said, if hacker has physical access to the system, hacker can easily bypass the password, right? So this is one method of cracking the password. There are so many different techniques. This is one technique, right? Now let's say hacker got access to our computer. Hacker is successful in bypassing our password. So once hacker is successful in bypassing our password and hacker can log into our system, can hacker access all the data that's available on our system? Hacker can access all the data that's available on our system, right? So whatever data is present on your C drive or D drive and all, hacker will be able to access that content, right? And generally speaking about user behavior, right? If you are using your computer and you try to log into a website and all, right? Does your web browser ask you, do you want me to remember the password? So when you are trying to log into a website, does the web browser give you an option? Does it ask you, do you want me to remember the password, whatever you have typed? Yes, it will ask you like, do you want me to remember the password? And then as a end user, what we do is because we are always in a thought that, okay, anyway, this is my computer and I'm the one who is going to use it. And of course, also because of laziness, right? Who is going to type the user ID and password and all every time we log in? Because there are instances where you may have to log into the same website multiple times in a day, right? So whatever the reason, right, we say yes, save the password, right? So next time whenever you try to visit the same website, you don't have to type the password and all, right? So you directly visit the website, your web browser will automatically dump that user ID and password there ready, right? And you can directly log in. Very simple. But assume your computer has been compromised by a hacker. So someone got physical access to your computer and hacker was able to bypass your password. Can this hacker also see all the user IDs and passwords that you have saved on your web browser? Is it possible? So let us check. If I say go to this Firefox, right? I can go to the web browser settings, right? Or in the newer versions of Firefox, this passwords option is directly visible here, right? So you don't even have to open the what do we say, the browser settings and look for it, right? So that option is directly visible. So now, as you see, it says for this particular website, facebook.com, some user ID and password information has been saved. Some user ID password information is saved. And as you all see, the user ID is saved in clear text and the password is hidden, but I can click on this I symbol. So when I click on the symbol here, it shows me what was the saved password, right? So there is some user ID and password saved, right? And now here, as you see, that saved password is visible, right? Is it clear? Same thing happens with your Google Chrome or any other web browser, right? So if you have saved some user IDs and passwords, right? A hacker will be able to view all those usernames and passwords after bypassing your system login, right? So once the hacker is successful in bypassing your system login, hacker will be able to see all your saved usernames and passwords. Is it dangerous? A hacker being able to view all your saved user IDs and passwords. What do you say? Is it dangerous? It's very dangerous, right? So are we supposed to save user IDs and passwords on our system? That's on our web browsers and all. So we are not supposed to save the user IDs and passwords on our web browser, but unfortunately, if you end up saving the user ID and passwords and somehow if a hacker manages to bypass your authentication, all those user IDs and passwords what are saved on your web browsers can be compromised, right? Same thing if I go into Edge or Google Chrome based web browsers, right? Uh, you can go into the settings and then you can just search for passwords. So in the passwords, right? If you have some saved user IDs or passwords and all, it will be showing you all those saved user IDs and passwords. So as of now, on this mission, means on this particular web browser, user IDs and passwords are not saved, so it is not showing me, right? But as I've shown you in Firefox, so what all user IDs and passwords are saved, all those things will be visible to the hacker. And then when you speak about passwords, right? Uh, Not only passwords which are saved on your web browsers and all, once a hacker is successful in bypassing your login ID, right? Hacker can also try to capture your password hash values and try to crack them, right? Now, as I said, uh, all your password hash values and all, right, will be saved on the system. If it is a PC, if it is a web page or something, those will be saved on your server, right? So now when I speak about a system, where exactly does your operating system store these usernames and passwords? So guys, where does your operating system store the username and password? So it's going to save all this username and passwords in SAM file, right? So what is SAM? No, it's not sequence aligned map. SAM is security accounts manager, right? So security accounts manager or SAM is a file where your operating system is going to store all the user information, that is the username and also your password hash value, right? So as we discussed earlier, it's not going to save your password as a clear text, right? It is going to create a hash value of it and it is going to save the hash value of the password. So when you speak about the location, that would be present on your C drive, Windows, System 32, config, SAM. So this is the location where you have the file. Okay, so this is the location where your SAM file is located. And as I said, the SAM file is saving your user IDs and passwords. Now, one unfortunate thing with the SAM file is you will not be able to copy the SAM file and all, right? You'll not be able to copy and paste it onto your external drive or somewhere. You'll not be able to open the contents of this SAM file and directly view it, right? So the contents of SAM file are locked. You'll not even be able to move it, right, from the default location of the SAM file to some other location and all, right? So as long as your operating system is up and running, the SAM file is locked by your operating system, right? The SAM file will be locked by the operating system as long as it is up and running. So you'll not be able to uh, make any activities like making a copy of the SAM file or moving it from the default location to a different location and all, right? But we don't have to worry. There are some tools which will help you to access the content of SAM file, right? There are certain tools which will help you to access the content of SAM file. But before we look at those tools, as I said, your password is not stored as a clear text password, but your password is saved as a hash value. So whatever the password you have created for the user account is saved as a hash value. So now the problem is, even if I give you a tool which can access the content of SAM file, that particular tool is only going to show us the hash file, right? It will show us the hash value. So if we are only getting the hash value, how do we get the password? And on our login screen, there is no option for us to give the hash value, right? On the login screen, we don't have an option to give the hash value. So we have to type the password only. That's the only option that we have. So in such condition, what should we do? So guys, as we don't have an option of giving the hash value on our login screen, even if there is a tool which will show us the hash value, will it really be useful? So the hash value itself will not be useful for us to log in, but here we are speaking about a hash value that is related to a login password, right? So as I said earlier, if you recollect, a hash value can be used for many things, right? So whatever the input is, you will be able to create a hash value for it, right? But here I'm speaking about hash values that are generated very specifically for passwords, right? Now, when you speak about a password, if you have to create a new password for your user account, what all characters would you consider for creating a new password? Will you use alphabets? So guys, will you use alphabets, lowercase and uppercase alphabets? You'll use numbers and special characters, right? So whoever is going to create a password, whether I am creating it or you are creating or anyone else, right? These are the options, right? Alphabets, numbers, and special characters. So these are the things that we are going to use for creating a password, right? Now, what hackers have done, because any user has to use these alphabets, numbers, or special characters to create a password, they found a way to get the actual password from the hash value. But again, remember, this technique, what we are going to discuss, will only be applicable for hash values related to passwords. So if I've taken a paragraph or I've taken a software code and created a hash value, the technique what I'm going to use now will not be useful. This is only for hash values related to your passwords. Right. So now in this case, as we all use alphabets, numbers, or special characters for creating passwords, let us say as a hacker, you take up alphabet A, calculate the hash value of it, and then compare it with whatever hash value you see on the computer, right? You take up alphabet A, calculate the hash value of it, compare it with whatever hash value you see on the system, right? On the SAM file. Now let us say the hash value is same. The hash value, whatever you have saw in the SAM file and the hash value, whatever you have calculated, are both same. Can you say the user account password is A? If the hash value, whatever you have seen in the SAM file, and the hash value that you have created for alphabet A, both are same, can you say the user account password is A. Yes, because as we have seen earlier, when we are using the hash calculator website, unless your input is same, the calculated hash value will not be the same, right? So only if your input is same, the hash value will be same. So if I take up alphabet A and I calculate a hash value, and that hash value matches with whatever is there in SAM, so it means that the user, when they are creating that user account and the password, they have given the password as A. But of course, let's say the password A is not matching, means the hash value of password A is not matching. Then you go with the next alphabet, let's say alphabet B, right? Calculate the hash value. Try to see if this hash value will match with whatever you have seen on the SAM file. But let's say, unfortunately, this also did not match. Take up C, D, continue till Z. Now let's say unfortunately none of the hash values that we have calculated are matching with the hash value what we have seen in the SAM file. Maybe there is a chance the password is not a lowercase alphabet, it might be a uppercase alphabet. So hacker will try the same thing. Take up uppercase alphabets till Z, try to see if the hash values match. Let's say if it is not matching, right? Then try to see if the password is a number. So this also did not match. Maybe then try to check with all the special characters and all, right? Let's say this also did not match. So then it tells us that the password of that user account is not a single character password, right? So it may be two character password. So if it is two character password, again repeat all the procedure with two characters. Take up the first character as A, second character, keep changing it, right? So like this, continue testing all possible combinations of lowercase and uppercase characters and all this, right? Till you are able to generate a hash value that is looking exactly similar to what you have seen in the SAM file, right? Now let's say after testing few combinations, will you come to this combination ZOOM at 123 after trying few combinations? So guys, what do you say? After testing few combinations, you will come to this ZOOM at 123. And then whatever the hash value you are going to create for this will be an exact match to whatever the hash value you have seen in the SAM file. So can we say that this is a correct password? Can we say that Zoom at 123 is the correct password for that user account? Yes, right. We can say that Zoom at 123 is the correct password for that user account, right? If the hash value what we have created for this combination of alphanumerics is exactly same as the hash value that you see in the SAM file. Okay, now this particular procedure where you are going to test all possible combinations of alphabets, numbers, special characters and all to crack up hash value, you call this as brute force attack. You call this as brute force attack. Okay, so is it clear what is brute force attack? Vijay, we'll discuss about the tools. We'll first understand the concept and then we'll go to the tools. Okay, I'll show you. So now when you speak about brute force, let me show you uh, a simple web page which tells us how easy or how complex it is, right, to perform this brute force. All you need to do is just perform a simple search with brute force time calculator. So Google will give you with multiple results, right? So from that, we'll go with a website called Better Buys. Okay, so this is the web page that we'll be using, betterbuys.com, estimating password cracking times. So click on that. Okay, so let it load the page. So it has to give us a password calculator here. So let us load for the, so let us wait for this web page to load the contents. Okay, so let me give some password here, right? It will tell us how long it's going to take to crack that particular password. So let me say I give a password as Zoom, and here as you see, it says it just takes 18 milliseconds to crack that particular password, right? Let me say I'll go with Zoom 123 as a password. Now, as you see, uh, the application says to crack a password Zoom 123, which is 7 characters. It needs 1 hour 16 minutes, right? So that's the time taken to crack the password Zoom 123, right? But generally, we were advised that your password should be 8 characters. So let me say the password is going to be Zoom 1234. Now see the difference to crack a 7 character and a 8 character password. Zoom 123, a 7 character password. It says it is going to take 1 hour 16 minutes to crack this. If I use Zoom 1234, as you see, 8 characters, only one additional character has been used. Now the time to crack this particular password has increased from 1 hour 16 minutes to 1 day 21 hours. So can I say by increasing the length of your password complexity increases and it becomes difficult for a hacker to crack it? So by increasing the length of a password, you can increase the complexity of the password, and it becomes difficult for a hacker to crack that particular password. Right. Now, what I do is keeping the password length as 8 characters instead of just going with alphabets and numbers. Let me also use maybe a special character. So let me say I'll take up my password as something like zoom @123. Now see, earlier it was telling us some 1 day, some 16 hours, something, right? Now for the same length, 8 characters, but there's one special character included now. Now it is saying that to crack the password, it would require 8 months, 4 days. So in addition to alphabets and numbers, if I also include a special character, right, it's going to increase the password complexity, right? And it's going to take even longer time for a hacker to crack it, right? Is it clear, everyone? Uh, just for a check, let us make one of these alphabets as uppercase, because as of now we have all 4 characters as lowercase alphabets. So let me say I'll make one character as uppercase. Now see, 8 months has now become 9 years. So can I say by including an uppercase alphabet, I am successful in increasing the password complexity further? So I'm still maintaining the password length as 8 characters, but just by adding few additional character types, like I've included a special character, the password complexity has increased. Then I'm also including a uppercase character, the password complexity has increased further, right? So which will make things more complicated, and it will require more time for a hacker to crack it. Right? So do you think brute force is really a feasible attack? What's your opinion? Can we depend on brute force? No, we will not be able to depend on brute force because first thing, it takes a long time, right? Brute force takes a long time. Is there any way for us to speed it up to reduce the time? Can we do something to speed up this process? We can. What we can do is try to use more and more powerful systems, right? Try to use a very powerful system. Maybe now let's say the system what I'm using now is able to create 1000 password hashes per second. But if I can increase the system's performance, maybe if I can take a better hardware, instead of maybe 1000 password hashes per second, maybe it will try to create 5000 hashes per second or 10,000 hashes per second. Right. But again, the problem is it's not that easy to increase the hardware resources. It's not that easy for you to increase the computing resources because hardware is very expensive, right? So what hackers do, they use two different things to crack these passwords via brute force. One method is they try to use multiple computers. So instead of using one computer, right, they try to use multiple computers, right, and distribute the load. So instead of one computer trying to crack a hash, now let's say I can take up 10 computers or 20 computers and distribute the load here. So now it's like I have 20 computers all working together to crack a hash, right? Now can I reduce the time taken to crack this hash value? I have 20 computers, right? And let's say on one computer it is going to take 100 hours to crack the hash. Now, when I include 20 computers, I'll be able to do it in 5 hours because there are 20 systems working on, right? And the second option, right? Because including so many computers is also not a easy task, right? Of course, when you use so many computers together to crack the password, you call it as a high performance cluster, HPC, right? We call it as a high performance cluster. But again, taking 10 computers, 20 computers, 100 computers is not an easy task. So what hackers can do, even though it is only one or two computers that they can have in a cluster, try to use powerful graphic cards. Now, why did a graphic card come into picture here? We are speaking about password cracking. So does graphic card have something to do with password cracking? We are not speaking about playing Call of Duty or GTA 5, right? So why graphic cards? Any guess? Simple thing. When you speak about your system, your CPU, have you come across terms like dual core, quad core, octa core, right? Maybe even if you did not come across that in your PC, maybe on your mobile phone, you should have surely come across that octa core CPU, deca core CPU, and all, right? So if you take up a processor, let's say I'll take an example of octa-core processor. It will have 8 processing cores, right? An octa-core processor is going to have 8 processing cores, right? And then it means there are 8 cores which can do the calculations. So in short, it means you have 8 units which can do some mathematical calculations. Now, when you speak about a graphic card, what is the job of a graphic card? Why do we use graphic card on our systems? Is it a processor? A graphic card is also a processor, right? So it is dedicated only to process the graphic information. Of course, your Core i5, Core i7, they are also processors, right? But to be very specific, you have to call them as application processors, right? And then when you speak about a graphic card, it is also a processor, but very specific to the graphic part, right? Now, when you say graphic, generally your graphic cards or your GPU is more powerful than a CPU, right? For a simple reason, when you speak about a graphic card, what it tries to do is calculate the RGB value, red, green, and blue value for each pixel on your screen. Now, you're all aware of different terminology, right? We always speak about HD, full HD, right? So different resolutions, even for your screen, your television, your mobile, and all. We speak about different resolutions, right? So this resolution, in the sense, now if I speak about HD resolution, it's like 1280 by 760, sorry, 720. So it means 1280 dots horizontally, 720 dots vertically. If I speak about full HD, 1920 dots horizontally, 1080 dots vertically. So in the same way, you go with 2K, 4K and all, the resolution keeps increasing. Now, these dots are generally called as pixels, not your mobile phone. The dot is called as a pixel. Each pixel will represent a value, red, green, and blue. So based on the value of red, the intensity of green and blue, you will be able to see different colors on your screen. Now imagine you start playing a game, right, where you have a full screen view where maybe there is a vehicle or there is a person or something. It has to show you all the buildings and all those things in the surroundings, shadows on your car, the person, the people moving around and all. Does it require a lot of processing to calculate the color, the intensity and all for each and every pixel on the screen and display it? Yes. So imagine 1920 into 1080. So you are speaking about millions of pixels, right? And for each of this pixel, intensity of three different colors have to be calculated and has to be projected onto the screen so that you will be able to enjoy the game. Now all that hard work is being done by your graphic card or your GPU, right? So these GPUs are thousands of times more powerful than your CPU in calculations. I'm not speaking about application logic or anything. I'm only speaking about raw power in performing calculations. Now, why I'm only speaking about raw power in performing calculations? If you have to perform brute force, what actually are we trying to do? We are taking a combination, maybe some combination, something like this. And for this combination, we are calculating a hash value. Is it correct? We take up some combination and we calculate a hash value for that particular combination, right? So can we say brute force is all about calculations, calculating the hash values, right? So here, which one do you think would be a efficient device, a CPU or a GPU? A GPU is more efficient, right, in doing these calculations, right? More powerful compared to a CPU, right? So what these hackers do, they start building systems with multiple GPUs. So I'm not speaking about one single graphic card. They start building systems with multiple GPUs, 6 to 8 GPUs on each system, and they try to make multiple systems like this, and then create a cluster from this. So imagine how expensive things would be. And if you guys have been following the GPU market for the past 6 months or 1 year, you would have identified the GPU prices are increasing. And to be very specific, graphic cards are being sold in black market, right? Twice, thrice, 4 times the actual price, right? Now imagine a hacker trying to get 6 or 8 graphic cards for each system and then trying to create multiple systems with 6 or 8 graphic cards and all to crack a password. It's not really economical, right? Not really uh, easy to do thing, right? So to overcome this problem with the brute force, hackers have come up with a different approach. What they are doing now, they say trying to crack the password one by one using brute force is not really easy, right? Let us guess what could be the password. Now, maybe take up a notepad, try to guess what could be the possible password. Maybe you are able to make, say, some 500 words, right? Ask your friend to take up a notepad, try to guess and make a note of all the possible passwords, whatever your friend might come up with. Let's say your friend has come up with another 300 or 400 passwords. Ask someone else, right? Ask them to write down all the passwords, whatever comes to their mind, right? Now, like this, maybe you're asking 10 people or 20 people, right? And then finally, you take up all the words from all different people, put it onto one final sheet. Now, let's say you are now able to get some 10,000 unique words, right? Now you are able to get some 10,000 unique words. That might be a possible password, right? So now whenever you come across a hash value on the SAM file, can you take up word number one, calculate a hash value, compare it with the SAM file hash, see if it is matching or not. If it is matching, whatever the word you have taken here is the correct password. Say it is not matching. Take up the second word, take up the third, fourth, fifth. Now, how many combinations are you going to test like this? 10,000, because that's the number you have in your uh, file there, right? Now, let's say when you are testing, say, some word 8640, you are able to generate the exact same hash value as what is there in the SAM file. So you know the password. You directly take up that word and you say, yes, this is the correct password, right? Will this process be much faster than brute force? In case of brute force, right, you're just trying to continue calculating, right, multiple combinations, right? But here you have some specific number of words that you have in a file and you're only trying to test it. So will this approach be faster than brute force? Yes, it's going to be faster than brute force, right? And this particular file, what you're creating with all the possible words that you think might be a correct password, you call this particular file as a password dictionary. So you're going to create a password dictionary. You try to see, right, if any of the word from this password dictionary might give you a correct password. If you're able to find the correct password, done, right? But what would be the probability? What are the chances that you are going to find a correct password using this password dictionary method? It's always going to be 50%. You have that specific word in the password dictionary, you will see the same hash, right? You'll be seeing the hash value that's exactly matching as whatever is on the SAM file. But let us say that specific word or that combination is not available in the password dictionary. Will you be able to see the exact same hash value? So guys, what do you say? If that exact same word is not available in the password dictionary, you'll not be able to see the hash. So in short, it means the probability of cracking a password successfully is only 50%. You have the word in the dictionary, you'll be able to crack it. You don't have the word, you'll not be able to crack it. But again, the problem here, the challenge, maybe you are taking a random combination of numbers or you are taking a specific word for the calculation. You still need a powerful system with multiple graphic cards and all to perform these calculations. What do you say? Whether you go with brute force or you are going with this dictionary method, right? You still need a system with multiple graphic cards and all to do the calculations because you are still trying to calculate the hash values. What do you say? Do we still need a powerful system? Yes. Now, the next approach, what hackers have come up with is something called a rainbow table. Now, what happens with the rainbow table? Hackers create a password dictionary. So they still try to create a password dictionary. They try to guess what could be the possible password and then create a password dictionary. But while a new word is being added into the password dictionary, They will also calculate the hash value of it and save it. So when you are adding a new word into the password dictionary, you are also calculating a hash value of that word and you are saving it into the dictionary. So now what happens when you are adding this directly into the password dictionary? Whenever you have to crack a password hash, do you need to recalculate all the hash values, or do you only need to compare if the hash value is available in the rainbow table? So when you are adding the word, let's say I'm adding a word Zoom. I calculate the hash value of Zoom and save it along with the word, right? Then I'm adding another word Zoom 123. I'm calculating a hash value and adding it into the dictionary. So if I calculate a hash value of all the words into the password dictionary and add it, in future, whenever I come across a hash value on a SAM file and I wanted to crack it, will I only need to do a simple comparison of the hash values, or do I need to recalculate the hash values every time? So I saw a hash value in the SAM file, right? And on my rainbow table, I'm already having all the words along with the hashes. So do I need to calculate the hash values again, or do I just need to compare the hash value, what I saw in the SAM file, with the hash value, whatever is already there on the rainbow table? What would be my approach? My approach is only comparison. I don't have to recalculate the hashes because they are already calculated and saved, right? So when the hash values are already calculated and saved, and I only need to go with the comparison, do I really require a very powerful computer with 6 graphic cards or a very powerful processor and all these things? Not necessary, because the hash value calculation is already done. All I need is a simple computer which can just do a comparison. A is equal to B. That's it. So even if I have a very basic computer, a Core i3 or a Core i5, I'll still be able to manage it. I don't have to depend on procuring expensive graphic cards, building a very powerful system using multiple graphic cards, or creating a high performance cluster and all. So rainbow tables will solve the problem, right? So even if hacker is not having access to a very powerful system, hacker can still go ahead and try to crack the passwords. So today, when you speak about hackers, they're actually using this rainbow tables. They're not using the password dictionaries or the brute force technique. Okay. So is it clear, everyone? What are the different kind of password cracking techniques, and what are the disadvantages of those techniques, and what is the new technique that hackers are using now? So you have brute force, you have password dictionary method, and you also have rainbow tables. And today hackers are mostly using rainbow tables, and even the tools what are being developed are being made in such a way, instead of brute force and all, they use rainbow tables, so things would be much easy, right? Things will be much easy there, right? So is everyone clear with this password cracking techniques, right? So if everyone is clear with the password cracking technique, then let me show you an application, right? Using which a hacker can obtain the hash values that are available in the SAM file, and also how a hacker can try to crack that, right? So I use an application called Lopcrack, which is not a free tool, but you can use it as a trial version, right? It's a commercial tool, but can be used as a trial version. So Lopcrack is the application that I'm using. install and run the application, right? Okay, so it says that your trial version will be valid for 15 days, right? So I'll proceed with the trial version. So this application, once you start it, it gives you a password auditing wizard. Say, start the wizard, continue. Now it will give you two options. It is asking you like, are you going to crack a Windows user password, or maybe is it a Unix-like system, right? When you say Unix-like system, Unix, Linux, FreeBSD, OpenBSD, Solaris, AIX, all those things, every anything based on Unix platform will be coming up there, right? So I say that I'm trying to crack the Windows password on this computer, right? So again, multiple profiles will be given, like quick password audit, or maybe do you want to go with the common passwords and all this. So I'll just say go with a quick password audit. So nothing else to be changed. So it will ask you to give permission to access the SAM file. Say yes. It shows you what all user IDs are available, right? Same as what we have seen earlier in the High-Ends Boot CD part. It shows you what all user IDs are available. It would use rainbow table, crack the password, and also show you what is the password. Right. So here it is showing you what is the cracked password. Right. Now this application uses rainbow tables, and that's the reason you are able to see the cracked password in such a short time. Right. If it was brute force, it would have taken at least few days. Right. And here if you see, I'm not even running this application directly on my physical computer. I'm just running it on a VM. So even with a virtual machine, it's very fast, right? So as I said, when you are going with the rainbow table, you don't really need a very, very powerful computer. You go with brute force or dictionary, yes, you will need a powerful system. Okay, is it clear how a hacker can try to use an application like lock crack and try to crack the Windows user account password? Guys, is it clear how a hacker can use lock crack to crack the Windows user account passwords? Yeah. So not only this techniques, right? Assuming a hacker is in our network, right? There are different things that a hacker can do, right? So we'll be discussing all those other techniques also in our next sessions, right? So is everyone clear so far, like what we have discussed today? What is the password cracking? What is hash value? What is encryption? How things are different, encryptions and hash values and all this? Chindu, as you are asking whether it is to be installed on your local system, if you are like able to install it on the local system of the admin, you can install it on admin system itself and you can do it. Or say you are able to copy this SAM file, right, from the admin's computer, you can also just give the path of the file wherever it is located. It will also do it. Okay. So I think, okay, I did not notice the time. So the next session, I'll show you how you can set up these virtual machines, right? The VM environment and all, right? Uh, so have you guys all downloaded these VMs, the ones which I have shared in the drive? Okay, so if you all have downloaded, okay, so in case someone has not downloaded, try to download and keep the VMs. So tomorrow I'll first start with how do you set up the VM environment and all, right? And then first, once we are done with it, then we'll discuss other attack methods. Okay. No, the VMs what you have used for your MCSC sessions will not be useful here, right? So I have shared separate VMs and all, so you'll be using those. Okay. Yeah. And okay. Harish, in case Windows 11 is not compatible on your system, you can use the Windows 7 VM. Right? So that's also there in the link what I have shared, right? And uh, Shashi, you don't have to worry about that. As I said, I didn't get access to the link, so I did not share it. So most probably by tomorrow morning, I'll be able to share you the link, right? So you can also download the tools and all. Harish, you can also use Windows 10, but if your VM is compatible with Windows 10, Windows 11 should also be working because Windows 11 is only a marketing name that Microsoft has changed, but internally it is all Windows 10. Yeah. So with this, I'll be ending the session for today. So tomorrow I'll show you how we start with VM and then we'll continue with the password cracking techniques. Thank you all.